Hi, welcome back to my channel, and for today's video, we will be answering some related questions for analytic geometry. For the first problem, it says here that for what values of k does or do the circle of this equation pass through the point 1, 1. So if this problem says it passed through that certain point, then that means the point satisfies the equation. Meaning to say that if we are gonna substitute this point here to this simply satisfies entirely. So to do that, either you substitute first the point or you simplify first the equation before substituting, whichever is more convenient to you. So in this case, I'm gonna simplify this equation first. So simplifying this equation, we have x squared minus 2kx plus k squared plus y squared minus 4ky plus 4k squared equals 10. So again, since the circle passes through the point 1, 1, then if I'm gonna simplify these and then make the substitution, it will satisfy entirely the equation. So what happened here is we have x squared and I have 2kx, I have y squared minus 4ky, and then I will make the chance of combining these two, so I'd get plus 5k squared equals 10. And so I would have x squared minus my x here, so I would have my x here is 1, my y here is 1, so this becomes 1 minus 2k plus 1 minus 4k plus 5k squared equals 10. And so simplified further, I would have 5k squared minus 6k, and then this becomes 2, and then this 10 will be transferred back to the left side. This becomes minus 8 equals 0. So if I'm gonna factor them out, I'd have 5k here, I would have k here, and so I would have 2 here, I would have 4 here. And remember, the last term is negative, so 4 and 2 have different signs, and then since the middle term is negative, the one that bears the higher value when we multiply bears the negative, so this one. Because if you multiply 5k and 2, you'll get negative 10, so this will be positive. So this implies that my k is negative 4 over 5, or k is equal to 2. So this is now the answer. So for the second problem, it says here that determine the value of k so that x squared plus y squared minus 8x plus 10y plus k is 0 is an equation of a circle of radius equal to 7 units. The equation of a circle is given by this h squared plus y minus k squared equals r squared. So your r here is the radius, and then h and k here is the coordinate of a center. Now, solve on that, I would rearrange the equation in such a way that I can follow the format. So I have x squared plus y squared minus 8x plus 10y plus k equals 0. And so if I rearrange that, I would get x squared minus 8x plus y squared plus 10y equals negative k. Then I want to convert this group of x's here, like the terms having the x, to create a perfect square term. And then same with the terms having y as variable. So in this case, to make it perfect square, because if you notice 8x, so the coefficient here is 8. So technique here is you divide it by 2 and then you square that. When I divide this by 2, I get 4, and then I square it, it becomes 16. Same here with the variable y. This is 25. And so that means to say I add 16 and 25 to the left side, which simply tells us that I should have to add the same to the right side. And so since this is now a perfect square, I would have x minus 4 square plus y plus 5 square equals minus k plus 41. So this means to say that my center now, the HK is 4, 5. Okay. However, in this case here, we're not concerned with the center of the circle. What is our concern here is to find the value of k that makes this equation having a radius equal to 7. So this means to say that minus k plus 41 is equal to 7 squared, which is 49. And so k here is equal to 41 minus 49, which is equal to negative 8. So therefore, this is the value of k. Okay, for problem number 3, find an equation of a circle passing through points 1, 1, 3, 5, and 5, negative 2. So in order for us to solve that, remember that these points here are actually points on the circle. You don't know what the center is, but in this case, you would have to assume, let HK be the center. If we are assuming that HK is the center, and then we can create systems of equations. So starting with the point 1, 1, that means to say that you would have 1 minus h squared plus 1 minus k squared equals r squared. So that would be our first equation. If we check on 3, 5, we would have 3 minus h squared plus 5 minus k squared equals r squared. And lastly, I would have 5 minus h squared plus negative 2 minus k squared equals r squared. So this would be now my systems of equation. If I'm gonna convert this equation here and I'm gonna simplify this, I would get this one as r squared equals h squared minus 2h plus 1 plus k squared minus 2k plus 1. This one as well becomes r squared equals h squared minus 6h plus 9 plus k squared minus 10k plus 25. And then I would have r squared equals h squared minus 10h plus 25 plus k squared plus 4k plus 4. If I'm gonna simplify this equation, so I'm not gonna discuss these basic styles in algebra here because we're actually talking here analytic geometry. So it's up to you to do the algebra thing. You would actually get the value of h as 5111, and then you would get k as 37 over 22. So just do the basic manipulation there. So you're actually solving the systems of equations simultaneously. And so solving for r, you can just get any of the points given here. So r squared is 6,625 over 484. So whether you can simplify that or not, that doesn't matter. So that's the r squared anyway. So therefore, your equation of a circle is x minus 51 over 11 square plus y minus 37 over 22 square equals 6,625 over 484. That's it. Problem number 4. So let UV be the point of intersection of the directrix and the axis of the symmetry of the parabola given by an equation of this one, and let u bar v bar be one of the endpoints of a latus rectum of the parabola. So find the area of the triangle bounded by the line segment joining uv, u bar, v bar, the x-axis, and the line segment joining this point here and the focus of the parabola. Okay, now in order for us to figure this out, let us simplify first this equation here, because this is actually the equation of the parabola. So in order for us to figure out how does the graph look like, so in order for us to do that, let's rewrite that equation into the standard form of the parabola. So I would get y squared minus 6x plus 3 equals 0. So if I'm gonna rewrite that, I would have y squared equals 6x plus 3 minus 3 rather. And so rewriting this further, I would have y squared equals 6x minus 1/2. So this means to say that my vertex is 1/2, 0. This means to say also that the length of the latus rectum here is the absolute value of 6, which is 6. And so based from this equation, it simply tells us that this value here, the coefficient here, is positive. This implies that the parabola opens to the right. This length of the latus rectum, which is the 4p, this simply tells us a story that p here is 3/2. So when this is 3/2, this simply tells us that our focus is 1/2 plus 3/2, 0. That means to say, starting from the vertex, you count additional of 3/2 distance from it going to the right, and that will be the location of the focus, because simply the parabola opens to the right. So this is equal to 0. So if you want to double check the other details for that, yes, you can. The directrix is given by the equation x equals -1, because that will be on the left side of your vertex. So it should be 3/2 distance from the vertex as well. So what happened now? If you plot this parabola, so you know that the vertex is 1/2, 0. So assuming I have a perfect drawing here, my focus is 2. So this is the focus, and then the vertex is somewhere here, 1/2, 0. Okay, and then the length of the latus rectum is 6, so that means 6 from up on top of the vertex, of the focus, and then below the focus. So you have 1, 2, 3. So this is the end point of the line segment for the latus rectum. And then 1, 2, 3. So this will be your another point. So the point here is 2, 3, and the other point here is 2, -3. And so your parabola will be like that. But our concern here, the problem says here that you should look for the area of a triangle bounded by the line segment joining UV. What is our UV again? It's the point of intersection of the directrix and the axis of symmetry. So this is actually the axis of symmetry already. This one. And we're looking for the directrix. But again, the directrix is 3/2 from the left of the vertex. So which means to say that our directrix is equal to x equals -1, and so somewhere here is the line of the directrix. So which means to say that this is the point of intersection of the directrix and the axis of symmetry. So you are actually looking for, you're creating a line here, So you are actually looking for the area of the triangle bounded by the line segment joining U, V, and U bar, V bar. So without loss of generality, this is U bar, V bar. I could have chosen this as well, but without loss of generality, I'll just pick this one on top of the x-axis. So this will be the boundary here, this one. And guys, we already know for a fact that this is 3, this one. So this represents the height, and the base here is 2p actually. So which means to say that 2p, that's 3 over 2 for equal to p, so this one is also 3. So the area of the triangle is 1/2 base times height, and so I have 1/2 3, 3, so the answer is 9 over 2 squared unit. So this is the answer we're looking for. So problem number 5. Let E1 be one of the endpoints of the conjugate axis of the hyperbola, which happens to be the intersection of the lines 3x minus 2y equals 0 and 2x plus 3y minus 13 equals 0. So suppose further that E1 is 2 units above the center of the hyperbola. Find an equation of such hyperbola when the distance of E1 to one of the vertices is square root of 13 units. Now, this is the intersection of 3x minus 2y equals 0 and 2x plus 3y minus 13 equals 0. So to solve for this, that means to say we're actually solving for the intersection. So 3x plus 2y equals 0, and I have 2x plus 3y equals 13. So this is the system of my equation. And so solving for this one, I would get, okay, bahala na kayo sa algebra nyo, I would get x equals 2 and y equals 3. So that means the intersection is 2, 3. So meaning to say that if you have this Cartesian plane here, so somewhere in this part is E1, and it says here that this is actually the endpoints of the conjugate axis, and it says here that E1 is 2 units above the center of the hyperbola. So if it's 2 units above, technically this one here is the center. So the point here is 2, 1, because this one here is 2, 3. Okay. So I know already that this is the conjugate axis, so 2 units here and another 2 units here. So I have E2 here. Okay, my next problem is, it says here that E1 is square root of 13 units to one of the vertices. So meaning to say that if this is our principal axis here, meaning somewhere here is the vertices, the distance from E1 to V is square root of 13. That means to say that, remember in the parts of hyperbola, this one represents A, the distance from the center to the vertex is A, and the distance from the center to one of the endpoints of the conjugate axis is given by. Okay, so to solve, that means to say that to solve for A, we use the Pythagorean theorem. So you have A squared is equal to square root of 13 squared minus 2 squared. So the answer here is 13 minus 4, it's 9. So meaning to say that A here is 9. So the information now is enough for us to establish the equation of the hyperbola. So how do I know that it follows a certain equation? Because it could be the hyperbola is with respect to the horizontal orientation or the vertical orientation. Now in this case, since the principal axis lies parallel to the x-axis, that means to say it's a horizontal orientation. Meaning to say if this is horizontal orientation, we have x minus 2 square over our a, which is 9, minus y minus 3 square over 4 equals 1. So this is now the equation of the hyperbola. That's it. So our last problem here is find an equation of the region bounded by the latus rectum of the parabola whose equation is given by y minus 1 quantity squared equals 6 times x minus 3 over 2. And the lines formed by connecting the origin to each of the endpoints of the latus rectum. So how do we do that? Okay, remember we're given already with the equation of the parabola. So it's not that we're looking for the equation because it's already given. So this simply tells us that the vertex of the parabola is 3, 2, 1. Okay, so what's the implication for this? This means that our 4p, which is the length of the latus rectum, is 6, implying that our p here is 3 over 2. Okay, and obviously this opens to the right because the equation here is positive on the coefficient value. Now, let's double check first the focus. We already know the vertex is given by this, and then the focus is actually 3 over 2 units away from the vertex. Simply because the p is 3 over 2, and it should be on the right side of your vertex because your parabola opens to the right. So that means to say that 3 over 2 plus 3 over 2, you would actually get 3, 1. So this is now the focus. So if you're gonna plot on that one, the vertex is 3 over 2, 1. So that's equivalent to 1 and 1/2. So let's say this is 1 and 1/2. I see. So this is now the vertex. And then 3. So this is now the focus. And then we know that our p is 6, so that should be 3 on top of the focus and 3 below the focus are actually the location of the endpoints of those latus rectum. So 3 units on top of it, so that's actually 3, 4. And then 3 units below it, so 1, 2, 3. So this is 3, negative 2. This is the origin. So you're actually asked to find the area of the region bounded by this. So remember, it says here that the lines connecting the origin to each of the endpoints. So this is the origin, so this is the endpoint. This one is another endpoint. And then you have to connect that. So if you notice, these are made up of 2 triangles. So the first triangle is the region here. So I should label this as A1. So that's the first area. And then the second triangle is this one. Sorry. So it should be the A2. Okay, so let's start first with the area of A1. Okay, so we know that this is the focus. So the distance from the focus to the endpoint is actually 3. So plus 1 here, so the height here is 4. Okay, this one. So 1/2 your base and your height is 4. So the base is starting from the origin to this point here, which is 3, 0. So that's 3. So the answer here is 6 square unit. So that only covers for the region here. So how about the second area? So the area 2 is 1/2. While our base here will be the same. Okay, so that will be 3 times the height here, however, is actually 2. So the answer is 3. Therefore, the entire area is the sum of the A1 and A2. So that's actually 9 square unit. That's it. So if you have any questions or clarification, you can comment down there so that I would know and we can discuss on that. So that's all for now. Guys, thank you so much for listening. So if you are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. And if you have any questions or clarifications, comment down there so that I would know and we can discuss on that. Thank you guys, and that's all for now. Have a great day.